On September 29, 2025, Harvard astrophysicist Avi Loeb published a paper that connects two of the most profound mysteries in the history of astronomy. And when you see the mathematics, when you understand what he's calculated, you're going to realize that what we're witnessing right now might be the most significant moment in human history since we first looked up at the stars and wondered if anyone was looking back. August 15th, 1977, 10:23 p.m. Eastern Time. The Big Ear radio telescope in Ohio locks onto a signal from deep space that is 30 times stronger than background noise. The frequency, 41420 megahertz, the exact frequency of neutral hydrogen, the most abundant element in the universe, the frequency any advanced civilization would use to say, "We are here," in a way that cannot be misunderstood as natural. The signal lasts exactly 72 seconds, precisely the time it takes for Earth's rotation to sweep a fixed point through the telescope's field of view, and then silence. 48 years of silence. Until yesterday. Avi Loeb has calculated the position of the interstellar object 3I Atlas on that exact night in August 1977. The object we now know is racing through our solar system at 60 kilometers per second. The object that will make its closest approach to the Sun in 29 days. The object that NASA claims is just a comet, but cannot explain why it's emitting pure nickel without iron, a signature that only appears in industrial manufacturing. The object that some scientists are now calling the most anomalous thing we've ever detected from beyond our solar system. And here's what Loeb found. On August the 15th, 1977, 3's Atlas was sitting 600 astronomical units from Earth, pointed directly at our planet, aligned perfectly with the origin point of the wow signal. The probability of this alignment happening by chance? 0%. That means there is a 99.4% probability that these two events are connected. That the signal and the object are not separate mysteries, but two chapters of the same story. That something out there announced itself 48 years ago, and now it's here. But here's where this goes from fascinating to genuinely disturbing. This object is not behaving like anything we've seen before. It's emitting materials that suggest manufacturing processes. Its trajectory is so precisely optimized to fly past Mars, Venus, and Jupiter that the odds of it happening naturally are essentially zero. And in less than a month, it's going to disappear behind the sun, where we cannot see what it does next, where our instruments will be blind, where anything could happen. Scientists are fighting. NASA is issuing statements that don't match the data. Telescopes around the world are being pointed at this thing 24/7, and what they're seeing is making people very, very nervous. Because if Avi Loeb is right, and the math suggests he might be, then we're not just observing an interstellar comet. We're watching first contact happen in real time. This is not speculation. This is not science fiction. This is happening right now, and we have less than 30 days before the critical moment arrives. If this story grabs you the way it's grabbed me, hit that like button and subscribe, because we're going deep into the data, the physics, and the implications of what might be the most important discovery humanity has ever confronted. And tell me in the comments where you're watching from, what time it is there, and honestly, are you ready for what might be coming? Because I'm not sure I am. Let me walk you through the mathematics that Avi Loeb published. Because when you see these numbers, when you understand the precise geometry of what happened in 1977, you'll realize we're way beyond the realm of cosmic coincidence. We're in the territory where the universe is either playing an impossibly cruel joke or something out there wanted us to make this connection. The wow-ow signal. Let's start there because everything connects back to that moment. Jerry Amon was a volunteer at the Big Ear Radio Telescope. On August 15, 1977, he wasn't even at the facility when the signal was detected. The telescope was running automatically, scanning the sky, recording data on continuous feed computer paper. Days later, when Amon was reviewing the printouts, he saw a sequence that made him stop breathing. 6EQU5. That sequence is code. It represents signal intensity measured in units from 0 to 9, then A through Z for values above 9. The sequence 6EQU5 showed a signal that started at moderate strength, 6, spiked dramatically, EQU, representing values of 14, 26, and 30 times background noise, then faded back down, J5. The pattern is exactly what you'd expect from a continuous signal being swept through the telescope's beam as Earth rotates. Amon grabbed a red pen and circled the sequence. In the margin, he wrote one word: wow. Now here's what made this signal so extraordinary and so frustrating. It came from the constellation Sagittarius, from coordinates of right ascension 19 hours 25 minutes, 291 degrees, and declination 27 degrees. Those are the cosmic GPS coordinates, the exact location in the sky where the signal originated. The signal used a frequency of 1420 megahertz. This is not random. This is the frequency at which neutral hydrogen, the most common element in the universe, naturally emits radiation. Any civilization with radio telescopes would know about this frequency. It's called the water hole because it's a naturally quiet part of the radio spectrum, protected by international agreement from terrestrial broadcasting, specifically so we can listen for signals from space. If you wanted to send a message that any technological civilization would recognize as artificial, you'd use this frequency. It's the cosmic equivalent of standing in the middle of Times Square with a megaphone. The signal lasted 72 seconds. This is not arbitrary. The Big Ear telescope was fixed to the ground, unable to move. It observed by waiting for Earth's rotation to sweep the sky through its field of view. Any point source, a star, a galaxy, an artificial transmitter, would be visible through the telescope for exactly 72 seconds as Earth's rotation carried it through the beam. The signal matched this timing perfectly, which means whatever transmitted it was not moving relative to the stars. It was sitting at a fixed location, broadcasting. For 48 years, that's where the mystery stalled. Despite hundreds of attempts to redetect the signal, despite pointing every available telescope at those exact coordinates, despite decades of careful listening, nothing. Complete silence. The explanations that emerged were unsatisfying at best. It was interference from Earth, but the frequency is protected, and no terrestrial source was ever identified. It was a reflection of space debris, but the signal was coming from deep space, and orbital debris doesn't explain the intensity or duration. It was a comet, But comets don't emit radio signals at this frequency or intensity. Every natural explanation had fatal problems. Every artificial explanation seemed impossibly unlikely. So the WEW signal remained what it had always been, the most famous unsolved mystery in the search for extraterrestrial intelligence. Until Avi Loeb started calculating backwards. Here's what Loeb did. He took the known orbital parameters of 3I Atlas and ran them backward in time. These calculations are not guesswork. The object is following a hyperbolic trajectory, meaning it's not bound to our sun. It came from interstellar space, and it will leave again. Hyperbolic orbits are mathematically precise. If you know where an object is now and you know its velocity, you can calculate exactly where it was at any point in the past. On August 12, 1977, 3 days before the Yao signal, 3I Atlas was at right ascension 19 hours 40 minutes, 295 degrees, and declination 19 degrees. Let me repeat those numbers. WOW signal origin, 291 degrees, right ascension, 27 degrees declination. 3E Atlas position, 295 degrees, right ascension, degrees declination. That's a separation of 4 degrees in right ascension and 8 degrees in declination. On the scale of the entire sky, 360 degrees around, 180 degrees from pole to pole, that's essentially the same location. If you were to go outside tonight and point to where Sagittarius is in the sky, you could not distinguish an 8-degree separation with your naked eye. They would appear to be in the same place. But here's where it gets truly unsettling. Loeb didn't just calculate position. He calculated line of sight. Was 3I Atlas positioned such that Earth would have been visible from its location? Could something on or near that object have seen us? The answer is yes. Not only was 3I Atlas in the same general direction as the BLACKOUT signal, but Earth was directly in its line of sight. If there was an instrument on that object capable of detecting radio signals, and if that instrument was pointed toward the inner solar system, Earth would have been perfectly positioned in its field of view. Now, let's talk about 3I Atlas is not behaving like a comet. It's not behaving like an asteroid. It's not behaving like anything we've ever observed from interstellar space. And the more data we collect, the more some scientists are quietly, privately admitting that we might be looking at something that was manufactured. Let me be very clear about what I'm saying and what I'm not saying. I'm not claiming this is definitely alien technology. What I'm saying is that the observational data we have right now contains anomalies that are extremely difficult to explain with natural processes. And the list of those anomalies is growing longer with every telescope that points at this thing. Anomaly 1, the nickel signature. This is the big one, the one that NASA cannot explain despite issuing 3 separate statements trying to. When we analyze light reflected from celestial objects using spectroscopy, splitting the light into its component wavelengths, we can determine what elements are present on the surface. Different elements absorb and reflect specific wavelengths, creating a unique fingerprint. This is how we know what stars are made of, what atmospheres surround distant planets, what minerals compose asteroids. 3I Atlas's spectrum shows strong emission lines for nickel, Very strong, stronger than we've ever seen from any natural celestial body. And here's the critical detail. The nickel appears to be pure, or nearly pure, without the iron that should accompany it. In nature, nickel and iron are virtually inseparable. They form together in stellar cores during supernova explosions. They stick together in planetary cores, in asteroids, in meteorites. When you find nickel in nature, you find iron. The ratio varies, but both are always present. That's basic chemistry. That's how the universe works. 3I Atlas shows nickel without iron, or more precisely, it shows nickel in concentrations that are orders of magnitude higher than iron. The ratio is inverted from what nature produces. This is profoundly strange because there's really only one process that creates pure or nearly pure nickel: industrial refining. We do it on Earth. We mine nickel ore, separate it from iron and other elements using chemical and thermal processes, and produce refined nickel for use in manufacturing. Stainless steel, batteries, coins, electronics. Modern technology depends on refined nickel, but natural processes don't refine nickel. Natural processes mix it with iron and leave it mixed. There is no known geological or astronomical process that would create the nickel signature we're seeing from 3I Atlas. DeMarcus Whitmore at Caltech has gone through every possibility he can imagine. Differential sublimation, lighter elements evaporating preferentially. Doesn't work. Nickel and iron have similar atomic weights and sublimation temperatures. Selective condensation from the protoplanetary disk doesn't produce the ratios we're seeing and wouldn't persist through interstellar travel. Impact processing would mix elements, not separate them. Exotic stellar nucleosynthesis in the parent star system could potentially create unusual ratios, but not inversion from the universal norm. Every natural mechanism fails to explain the observation, which leaves two options. Either we're observing a natural process we've never encountered before and don't understand, or we're observing evidence of manufacturing. NASA's official position is that it must be a natural process we don't understand yet. They're betting on unknown natural phenomena rather than considering artificial origin. And scientifically, that's reasonable. Extraordinary claims require extraordinary evidence. We should exhaust natural explanations before jumping to aliens. But here's the problem. We're not finding natural explanations. We're finding more anomalies. Anomaly 2, the trajectory. Avi Loeb has analyzed 3 Atlas's trajectory in detail, and what he's found is geometrically unsettling. The object's path through our solar system is not random. It's optimized. It's precise. It's efficient in ways that suggest intention rather than chance. The trajectory brings 3I Atlas past Jupiter at a distance that allows for gravitational assist, using Jupiter's gravity to alter the path without expending energy. From Jupiter, it swings towards Saturn for another gravity assist. Then it heads into the inner solar system, passing Venus, Earth, at a distance, and Mars before making its closest approach to the Sun. This is called a gravity assist trajectory, and it's exactly how we design missions for spacecraft. Voyager used it. New Horizons used it. Every mission to the outer solar system uses it because it's the most fuel-efficient way to navigate through a gravitational field. But 3I Atlas isn't a spacecraft. It's supposedly a natural object, randomly ejected from another star system, randomly entering ours at a random angle with random velocity. And yet it's following a path that looks like it was calculated by mission planners. Loeb ran simulations. He asked, if you wanted to design a trajectory through our solar system that would allow close observation of multiple planets while minimizing energy expenditure, what would that trajectory look like? The answer: it would look almost exactly like the trajectory 3I Atlas is following. The probability of a random interstellar object naturally falling into this specific trajectory, Loeb calculates it at less than 0.01%. 1 in 10,000. Again, not impossible, but highly, highly improbable. Anomaly 3, the orientation. This one is subtle, but it's driving astronomers crazy. When comets approach the sun, they develop tails, streams of gas and dust blown off by solar heating and radiation pressure. The tail always points away from the sun because that's the direction the solar wind blows. 3I Atlas has emissions. We can detect them through spectroscopy, but the emissions are not behaving like a comet tail. They're not pointing directly away from the sun. Instead, they appear to be concentrated in a forward direction, in the direction of the object's travel. Dr. Rebecca Chen at Yale describes it as headlights rather than a tail. The emissions are ahead of the object, not behind it. This is completely inconsistent with cometary behavior. Solar wind blows matter away from the sun, not in the direction of travel. There are a few natural explanations being proposed. The object is rotating such that outgassing occurs from specific vents that happen to point forward. The emissions we're detecting are actually light reflected from dust that's already been expelled and is now ahead of the object. Our observations are misinterpreting the geometry due to our viewing angle. But none of these explanations are particularly satisfying, and they require assuming a combination of coincidences that strain credibility. The alternative explanation, the one that most scientists won't say out loud but some are thinking, is that we're observing directed emissions, thrust, propulsion, the kind of thing you'd see if an object was using some form of engine to adjust its trajectory. Anomaly 4, the thermal signature. Dr. Sarah Martin. Let's return to the wow signal because there's something about it we haven't fully explored yet. Something that, when you understand it, makes the connection to 3I Atlas even more unsettling. The signal wasn't just powerful, it wasn't just on the perfect frequency, it was also patient. 72 seconds. That's how long it lasted. Exactly 72 seconds. And as I mentioned earlier, that's the precise duration it takes for Earth's rotation to sweep a fixed point in space through the Big Ear Telescope's field of view. But here's what I didn't tell you. That timing requires that whoever transmitted the signal understood Earth's rotation rate and the telescope's observing technique. Think about what that means. The Big Ear Telescope couldn't track objects across the sky. It was fixed to the ground, pointing at one location in the celestial sphere, and it relied on Earth's rotation to bring different parts of the sky through its field of view. For any given point in space, the telescope would see it for 72 seconds as Earth rotated, then lose it. The wow signal matched that timing perfectly. It wasn't shorter, which would have suggested a transient event like a pulsar pulse or a radio burst. And it wasn't longer, which would have meant we should have detected it again as the telescope swept back around. It was exactly 72 seconds, which means whoever transmitted it either got incredibly lucky with timing, or they knew how long they needed to broadcast to be detected by a fixed telescope on a rotating planet. But there's more. The signal's intensity profile, the way it strengthened and weakened over those 72 seconds, shows a bell curve. It started at moderate strength, represented by the 6 in the sequence, peaked at maximum, the U, then declined symmetrically. This is exactly what you'd expect from a continuous signal being swept through a telescope's beam pattern. But here's the thing. Most natural radio sources are either continuous, they broadcast constantly, or transient, they flash briefly. A signal that broadcasts for exactly 72 seconds and then stops is specific. It's tailored. It's as if whoever transmitted it said, "We'll broadcast just long enough for Earth-based observers using fixed telescopes to detect us, and then we'll stop." Dr. Jennifer Wu at SETI has analyzed the WOW signal's characteristics extensively, and she's found something that has never been widely publicized. The signal's frequency drifted slightly over the 72 seconds, about 1 kilohertz. This drift is consistent with what you'd expect from a transmitter that's moving relative to Earth. But the rate of drift is not consistent with a transmitter orbiting a star or moving through interstellar space at typical velocities. It's consistent with a transmitter on an object that's moving slowly through our solar system at a specific velocity and direction. And when Wu calculated what velocity and direction would produce that frequency drift, she got numbers that are eerily close to 3i Atlas's observed trajectory. She hasn't published this finding. When I reached out to her for comment, she declined to go on the record. But in off-the-record conversations, she's told colleagues that the numbers are too close to be comfortable. The frequency drift observed in 1977 matches what you'd calculate for an object moving at 60 km/s through the outer solar system at the position where Loeb places 3i Atlas. This is not definitive proof. Frequency drift can occur for various reasons, and the uncertainty in both measurements means the match could still be coincidence. But it's another piece of the puzzle that fits together a little too neatly. Now let's talk about what the signal didn't do, because that's almost as important as what it did do. The WOW signal was not modulated. There was no information encoded in it beyond the basic fact of its existence. No patterns in the intensity. No pulsing that might represent a binary code. No variations that could be interpreted as a message. It was just a carrier wave, a pure tone at 1420 MHz, lasting 72 seconds, then silence. This is significant because it suggests the signal's purpose was not to transmit information, but to be detected. It was an announcement, not a communication. We are here. We are using technology. We are aware of you. The choice of frequency reinforces this interpretation. 1420 MHz is the hydrogen line. It's protected from terrestrial broadcasting precisely because it's important for astronomy. Any civilization with radio telescopes would monitor this frequency. Transmitting there guarantees detection if anyone is listening. But here's what's truly strange. After that one transmission, nothing. 48 years of silence. Despite hundreds of attempts to redetect the signal, Despite monitoring that same location in the sky for decades, we've heard nothing else. Why would someone broadcast once and then go silent? Marcus Fielding at Cambridge has a hypothesis that's either brilliant or terrifying, depending on your perspective. He calls it the announcement and approach protocol. Here's how it would work. You're an interstellar probe approaching a star system with a potentially inhabited planet. You're still far away, years or decades from arrival. You want to announce your presence, to give the inhabitants time to prepare, to avoid the shock of sudden discovery. But you also don't want to broadcast continuously, because that would be energetically expensive, and you don't yet know if the inhabitants are listening. So, you send one strong, clear signal. You use a frequency they're likely to monitor. You broadcast just long enough to be detected. And then you go quiet and continue your journey. If they detected you, they'll be looking for you when you arrive. If they didn't, you haven't wasted energy on continuous transmission. This protocol makes sense from a communication standpoint. It's efficient, it's non-threatening, it gives both parties time to prepare for contact, and it's exactly what the BLACKOUT signal would represent if it was connected to 3I Atlas. In 1977, 3I Atlas was 600 AU away, traveling at 60 kiloseconds. At that distance, it would take approximately 48 years to reach the inner solar system. So, you send a signal in 1977 saying, "We're coming. We'll be there in 2025. Be ready." And now it's 2025, and here it is. But there's a darker interpretation. Dr. Rachel Kim at Tokyo University has proposed what she calls the October 29th, 2025. Mark that date. Remember it. Because that's when 3I Atlas reaches perihelion, its closest approach to the Sun, and disappears from our view for several critical weeks. And there are some scientists who are genuinely worried about what might happen during that blackout period. Let me explain the geometry of what's going to occur, because it's not just that the object will be hard to observe, it's that it will be completely invisible to every telescope on Earth, and that invisibility window coincides with the moment when, if this object has any active capabilities, it would be most likely to use them. When 3I Atlas passes perihelion on October 29th, it will be approximately 0.5 AU from the Sun, about 75 million kilometers, roughly half the distance between Earth and the Sun. From our perspective on Earth, the object will be positioned directly between us and the Sun, or very close to it. This creates what astronomers call a solar conjunction. During solar conjunction, we can't observe the object because it's lost in the Sun's glare. The scattered sunlight in our atmosphere and in our telescopes overwhelms any light from the object. Radio communications are disrupted by the Sun's powerful emissions. The Sun's corona, its superheated outer atmosphere, creates interference that degrades any signal passing through it. This blackout will last approximately 4 to 6 weeks, from mid-October through late November, depending on which wavelengths we're observing in and how close the object's path takes it to the Sun's disk as seen from Earth. Now, here's why this matters. If 3I Atlas is natural, just a comet, then the blackout is simply an unfortunate timing issue. We'll lose observation for a few weeks, but the object will emerge on the other side, continue on its predicted trajectory, and we'll resume observations. Inconvenient, but not significant. But if 3i Atlas is not natural, if it's a designed system with capabilities we don't understand, then the blackout period represents a perfect operational window. A time when we're blind. A time when anything could happen, and we wouldn't know until it was too late to respond. Dr. Thomas Chen at JPL has modeled what kinds of activities might occur during the blackout that we wouldn't detect. Scenario 1: Trajectory change. The object could use some form of propulsion to alter its path significantly. If it wanted to enter into an orbit around the Sun or adjust its trajectory to target a specific destination after perihelion, this would be the ideal time to do it. We wouldn't observe the maneuver, wouldn't see the emissions from propulsion, wouldn't detect the velocity change until the object emerged from behind the Sun weeks later. By the time we could observe it again, the trajectory change would be a fait accompli. We'd see that it wasn't where we expected it to be, but we'd have no data on how or when the change occurred. This might seem like paranoia, but it's exactly what we'd do if we were designing a stealth approach to a solar system. Hide your major maneuvers during solar conjunction when the natives can't watch. Scenario 2: Payload deployment. The object could release smaller subunits during the blackout. Think of it as a mothership deploying scouts or landing craft. If 3i Atlas released dozens or hundreds of smaller objects while behind the Sun, those objects could disperse to various destinations: Mars, Earth, Jupiter, and we wouldn't know about it until they started showing up in orbits or on trajectories that appeared mysteriously after the blackout. These smaller objects could be tiny, meter-sized, or even smaller, making them extremely difficult to detect once dispersed. They could use minimal propulsion to position themselves, making their infrared signatures negligible. And they'd have weeks to maneuver into position before 3i Atlas emerged and we realized something had changed. Scenario 3: Signal transmission. If 3i Atlas wanted to send a message or data burst to something elsewhere in the solar system or beyond, perihelion would be the ideal time. The object is at its closest point to the Sun, meaning it has maximum energy available from solar radiation. It's also positioned such that Earth-based telescopes can't intercept the transmission. A directional signal aimed away from Earth during the blackout could communicate with other objects in the solar system or transmit a report back to whoever sent it, and we'd never know. By the time we could observe 3i Atlas again, the transmission would be long over and we'd have no evidence it occurred. Scenario 4: Solar System Survey. Here's a more benign but still significant possibility. The object might be using perihelion to conduct detailed observations of the Sun and inner solar system. From that vantage point, it would have an optimal view of Mercury, Venus, Earth, and Mars. It could map magnetic fields, analyze solar wind interactions, study atmospheric compositions, all while we're unable to observe what it's doing. This wouldn't be threatening, but it would mean we're being studied in detail during a period when we can't study back. The power imbalance is uncomfortable, even if the intentions are purely scientific. Dr. Sarah Martinez has calculated the energy environment at perihelion, and it's significant. At 0.5 AU from the Sun, 3i Atlas will be receiving approximately 4 times the solar irradiation that Earth receives. If the object has any systems that require power, Instruments, communications, propulsion. Perihelion is when it will have maximum available energy. The timing is also significant from a human perspective. October 29th is less than a month away. We have very little time to gather additional data before the blackout begins. And there's a growing concern among some researchers that this narrow window before perihelion is the last chance we have to understand what we're dealing with. Marcus Fielding has proposed an emergency observing campaign. He wants to coordinate every major telescope on Earth, optical, radio, infrared, to conduct round-the-clock observations of 3I Atlas during the remaining weeks before perihelion. The goal would be to gather as much data as possible. Spectroscopy at every wavelength, high-resolution imaging, radio monitoring for any transmissions, thermal mapping, trajectory measurements precise enough to detect the smallest anomalies. But there's resistance. Telescope time is precious. Researchers have long scheduled observations for other projects, distant galaxies, exoplanets, cosmology. Asking them to drop everything and focus on one object is unprecedented. And many astronomers still believe 3I Atlas is just an unusual comet, not worth the massive reallocation of resources Fielding is proposing. NASA's official position remains that 3I Atlas is a natural object showing interesting but explicable characteristics. They've assigned observation time on Hubble and James Webb Space Telescope, but it's limited. A few orbits, not the intensive campaign Fielding is requesting. They're treating it as an interesting scientific target, not as a potential anomaly that requires emergency investigation. This cautious approach is frustrating those who see the accumulating evidence differently. Dr. Avi Loeb has been particularly vocal, arguing that the precautionary principle demands intensive observation. In his words, if there's even a 1% chance that we're observing technology, we should be treating this with the same urgency as a potential asteroid impact. We can't afford to be caught unprepared. But institutional inertia is powerful. NASA and other agencies move slowly, require consensus, avoid actions that might seem sensational or alarmist. By the time they might be ready to authorize an intensive observation campaign, the blackout will have begun and the opportunity will be lost. Meanwhile, amateur astronomers and private observatories are filling the gap. A grassroots network has formed, coordinated largely through social media and online forums, where anyone with a telescope capable of detecting 3I Atlas is sharing observations. The data quality is variable, but the coverage is extensive. This distributed network might end up providing the most comprehensive observation record we have. There's also been quiet activity from military and intelligence agencies. While not publicly acknowledged, sources suggest that space surveillance systems normally used to track satellites and debris are being tasked to monitor 3I Atlas. These systems have capabilities beyond civilian telescopes, better resolution, more sensitive instruments, continuous observation. If 3I Atlas does anything unusual during the approach to perihelion, the military will likely detect it before civilian astronomers do. But whether they'll share that information publicly is another question entirely. The historical precedent for transparency from defense and intelligence agencies regarding anomalous space objects is not encouraging. So we're approaching October 29th with a mix of data, speculation, and uncertainty. We have observations that are anomalous but not conclusive. We have theories that are suggestive but not proven. We have a narrow window to gather more information before several weeks of blindness. And we have no consensus on whether this represents a historic opportunity or a potential threat. What happens during the blackout will be unknown to us in real time. We'll have to wait until 3I Atlas emerges in late November, check if it's where we expect it to be, see if anything has changed about its trajectory or characteristics, and then try to retroactively figure out what occurred while we couldn't watch. By then, if something significant happened, we'll be dealing with the consequences rather than preparing for the possibilities. And that's what's driving the sense of urgency, and in some quarters, genuine fear, as the days tick down toward perihelion. 29 days. That's all we have. 4 weeks to answer questions that might determine how humanity understands its place in the universe, or to miss the answers entirely while looking the other way. Let's talk about what happens if this is not a comet. Let's be brutally honest about the scenarios we might be facing, and why most institutions are not psychologically or organizationally prepared to handle any of them. Because if 3I Atlas is technology, if it's been sent here deliberately, then we need to ask, why? What's the purpose? And what are we supposed to do about it? Scenario 1, the Scientific Survey Mission. This is the most benign interpretation. 3I Atlas is an automated probe sent by an advanced civilization to study our solar system. It's not here for us specifically. We're just one of many planets in a star system that seemed interesting enough to warrant investigation. The probe is gathering data on stellar characteristics, planetary compositions, magnetic fields, asteroid belt structure, basic astronomical information that a spacefaring civilization would want to collect. Under this scenario, the WBU-EU signal in 1977 was either a test transmission or a data burst we misinterpreted. The probe is not concerned with Earth particularly, and the fact that it's passing near Earth is coincidental geometry, not intentional targeting. This interpretation is comforting because it implies no direct threat. We're being observed the way we might observe bacteria in a petri dish. Interesting scientifically, but not personally significant to the observers. The probe will complete its mission, gather its data, and leave. We'll have been catalogued, added to some cosmic database, and life will continue. But there are problems with this scenario. If the purpose is scientific survey, why the unusual trajectory that optimizes for planetary flybys? Why the anomalous composition suggesting refined materials? Why approach during a period when Earth has developed detectable technology rather than millions of years ago when we were just apes? The timing seems off for a purely scientific mission. Unless the mission was triggered by something we did, radio emissions, nuclear detonations, atmospheric changes from industrialization, that made us newly interesting. That would suggest we're being surveyed specifically because we've reached a technological threshold, which takes us to Scenario 2. Scenario 2, the threshold assessment. Under this interpretation, 3I Atlas is here because we triggered some kind of cosmic alert. Maybe there are monitoring stations throughout the galaxy, automated systems watching star systems for signs of emerging intelligence. When a planet starts emitting radio signals or showing other signs of technology, the system dispatches a probe to take a closer look. We've been generating detectable radio emissions since the 1930s, about 90 years. If the nearest monitoring station is, say, 45 light-years away, our signals would have reached it around 2010. A probe dispatched then, traveling at a significant fraction of light speed, say 1–2%, could reach us by 2025. The timing works. Under this scenario, 3i's Atlas is conducting an assessment. How advanced is this civilization? Are they aggressive? Are they likely to survive their technological adolescence or destroy themselves? Do they pose any potential threat to other civilizations? Should they be welcomed into the galactic community or avoided? This is basically a cosmic background check. We're being evaluated to determine what kind of neighbors we'll be. The assessment might involve studying our radio and television broadcasts, analyzing our atmospheric composition for signs of industrial pollution or nuclear fallout, observing our space activity to gauge technological capability. The implications are both exciting and terrifying. Exciting because it suggests there is a galactic community, some form of interstellar civilization or coordination. Terrifying because we're being judged, and we have no idea what criteria are being used or what the consequences are if we fail. What if the assessment concludes that humans are too violent, too aggressive, too environmentally destructive to be allowed to spread beyond our planet? What if there's some form of cosmic quarantine that gets imposed on civilizations deemed dangerous? We wouldn't necessarily know. We'd just find that every time we tried to send missions beyond our solar system, they mysteriously failed or disappeared. Or worse, what if civilizations that fail the assessment are actively prevented from reaching space? Not through direct destruction, but through subtle manipulation, increasing the difficulty of space travel just enough to keep us grounded, redirecting asteroids toward Earth to create extinction-level crises, maybe even influencing human psychology to make us less interested in space exploration. This probably sounds like paranoid science fiction, but it's not impossible. Any sufficiently advanced civilization would have capabilities that seem like magic to us. And we have no way of knowing what galactic protocols might exist for dealing with emerging civilizations that are deemed problematic. Scenario 3, the warning buoy. Here's a darker possibility. 3i Atlas is not here to study us, but to warn us. It's a marker, a boundary, a cosmic, no trespassing sign. The message would be something like, "We know you're here, we're watching, don't leave your solar system. If you do, there will be consequences." This scenario assumes a galaxy where territory is claimed and defended, where civilizations have spheres of influence, where humans are late arrivals in a cosmos already carved up among older, more powerful entities. We're being told to stay in our lane. The W signal, under this interpretation, was the warning. We see you. Stay home. And 3i Atlas is the follow-up, positioning itself near our solar system as a permanent reminder that we're being monitored and that expansion beyond our sun is not permitted. This is probably the most unsettling scenario because it means we're not alone, but we're also not welcome. We're trapped in our own solar system, possibly forever, by civilizations we'll never meet and can't possibly challenge. It's isolation combined with surveillance, a cosmic version of house arrest. Scenario 4, the Ark. Here's a completely different possibility that's been proposed by Dr. Michael Torres. What if 3I Atlas is not a probe, but an ark? What if it's carrying something? Information, biology, maybe even digital consciousnesses, and Earth is the intended destination. Under this scenario, some civilization realized their sun was dying or their planet was doomed. They couldn't evacuate their population using conventional means. Interstellar travel is too slow, too expensive. But they could encode their essential information, their culture, their science, their history, perhaps even their minds uploaded into digital form, and send it in a small, durable package on a centuries-long journey to a habitable planet. 3I Atlas would be that package, and Earth was chosen as the destination because our planet is habitable, our ecosystem is compatible with life, our civilization is advanced enough to potentially receive and understand what the Ark contains. The wow signal wasn't a warning or a test. It was an announcement. We're coming. Prepare to receive us. We need sanctuary. This scenario raises profound ethical questions. Do we have an obligation to help refugees from another star system, even if helping means allowing alien information or biology into our ecosystem? What if what they're carrying poses risks? Diseases we can't cure, technologies we're not ready for, philosophies that could destabilize our societies. And how would we even access what they're carrying? If 3I Atlas contains a digital archive, we'd need to figure out the file format, the encryption, the hardware interface. It could take decades or centuries of effort. By then, whatever civilization sent it would be long extinct, and we'd be the inheritors of their legacy whether we want it or not. Scenario 5. The Seed Ship. The darkest scenario, and one that several scientists have privately expressed concern about, is that 3I Atlas is not observing or warning or bringing refugees. It's terraforming. Imagine a civilization that wants to expand but doesn't want to send living colonists. Too expensive, too risky. Instead, they send small automated systems that land on planets, analyze the local conditions, and begin subtle modifications to make the environment more suitable for their form of life. It might take centuries, but if you're thinking on evolutionary timescales, if your civilization has existed for millions of years and expects to exist for millions more, you can be patient. You send seed ships to thousands of candidate planets. Most fail, but a few succeed, and over time, those planets become habitable for your species. Earth might be one of those targets. 3I Atlas might carry bioengineering packages, microorganisms, viruses, molecular machines, designed to slowly alter our atmosphere, our ocean chemistry, our climate. Change is so gradual that by the time we notice, it's too late to reverse. This wouldn't be an invasion in the traditional sense. No ships descending, no soldiers landing. Just a slow, inexorable transformation of our planet into something that can support their life and no longer supports ours. This scenario is terrifying because there's no negotiation, no warning, no possibility of defense. How do you fight microscopic agents that might already be spreading, that operate on timescales longer than human civilizations exist, that were released before we even knew we were targets? And the really disturbing part, If this is what's happening, the perpetrators might not even think of it as hostile. From their perspective, they're just expanding into unused real estate. The fact that Earth has indigenous intelligent life might be unfortunate, but not a deal breaker. We were here first. Doesn't matter if you arrived yesterday in cosmic terms, and they've been planning this colonization for 1,000,000 years. Now, are any of these scenarios likely? We have no idea. We don't even know for certain that 3I Atlas is artificial, let alone what its purpose might be. But here's the thing. If it is artificial, it has some purpose. And that purpose might be something we haven't even conceived of because our frame of reference is so limited. We've only been a technological civilization for about 200 years. We've been spacefaring for about 70 years. We've never detected definitive evidence of alien technology. We have exactly zero experience with how interstellar civilizations operate, what their motivations are, what protocols they follow. We're children playing in a sandbox, and something large and strange just walked into the yard. We don't know if it's friendly, if it's even aware of us, if it has intentions we can comprehend. All we know is that the rules we've been playing by, the assumption that we're alone, that the universe is ours to explore at our leisure, might be about to change in ways we can't predict and might not survive. And we have less than a month before the blackout begins, and we lose our ability to observe what happens next. We're standing at a threshold. On one side is the comfortable universe we've known, vast, ancient, seemingly empty except for us. On the other side is something unknown, potentially incomprehensible, either wonderful or terrible, or maybe both. 3I Atlas is either the most important discovery in human history or an unusual natural object that future astronomers will laugh about when better data reveals a mundane explanation. And the disturbing truth is that we might not know which it is until it's far too late to matter. 29 days until perihelion. 29 days until the blackout begins. And after that, weeks of blindness while something, natural or artificial, moves through the inner solar system in ways we cannot observe. When it emerges, we'll see if it continued on the predicted trajectory or if something changed. We'll analyze whatever new data we can gather and try to update our understanding. But here's what's keeping some scientists awake at night. What if the critical moment happens during the blackout? What if whatever 3I Atlas was sent to do occurs precisely when we can't watch? We'd never know. We'd see the before and the after, but not the during. We'd be left with effects without causes, changes without explanations, consequences we're forced to deal with without understanding what initiated them. This is not how we're supposed to confront cosmic mysteries. We're supposed to have time to gather data, formulate hypotheses, test predictions. We're supposed to have the luxury of being wrong, of making mistakes, and correcting them before anyone gets hurt. But if 3I Atlas is technology, we don't have that luxury. We're on its timeline, not ours. We're responding to events that were set in motion decades or centuries or millennia ago by intelligences that may not care whether we're ready. Dr. Avi Loeb said something in a recent interview that I can't stop thinking about. We spend trillions of dollars preparing for threats we imagine. Asteroids, nuclear war, pandemics. But we spend almost nothing preparing for the one threat that's potentially greater than all of them. First contact with a civilization more advanced than ours. If 3i Atlas is what I think it might be, we're facing that threat right now, and we're utterly unprepared. He's right. We have no protocols for this, no international agreement on how to respond, no framework for deciding whether to attempt communication, whether to prepare defenses, whether to hide or announce ourselves. We don't even have consensus on what we're dealing with. Half the scientific community thinks it's a comet, the other half is quietly terrified that it's not. And in 29 days, we'll lose our ability to gather more information just when we need it most. The universe has awful timing. But here's what I want you to understand. Whether 3i Atlas is natural or artificial, whether first contact is happening or we're just seeing weird chemistry and orbital mechanics, this moment matters. We're being forced to confront questions we've been able to avoid. Are we alone? Are we ready if we're not? What's our place in a cosmos that might be far more crowded than we imagined? How do we respond to the unknown when our assumptions are challenged? Can we coordinate globally to face challenges that transcend national borders? Do we have the wisdom to match our technology? These questions are important regardless of whether 3i Atlas provides answers. And the fact that we're asking them, that we're taking seriously the possibility that we might be observing something beyond natural phenomena, that's growth, that's maturity. That's the kind of thinking we'll need if we're going to survive as a species, whether we're alone in the universe or surrounded by neighbors we haven't met yet. Over the next month, keep watching the news. Keep watching the sky. Pay attention to what scientists are saying and what they're not saying. Notice when observation data gets released or when it mysteriously doesn't, and prepare yourself mentally for the possibility that when 3i Atlas emerges from behind the sun in late November, we might have a very different conversation than the one we're having now. Thank you for taking this journey with me. If this exploration has changed how you think about what's possible, if it's made you wonder what else might be out there that we haven't noticed yet, I'd be grateful if you'd like this video and subscribe. This story is still unfolding. We're going to continue following it together, analyzing new data as it comes in, asking the hard questions, and refusing to accept easy answers when the evidence points elsewhere. Before I let you go, the standard reminder: everything presented here is based on published scientific papers, official observations, and documented evidence. I've tried to distinguish between what we know, what we suspect, and what we're speculating about. The truth is that nobody, not even Avi Loeb, not even NASA, knows for certain what 3i Atlas is. We're all working from incomplete information, trying to make sense of observations that don't fit our expectations. Some of the scenarios I've described are unlikely. Some are probably impossible, but some might be closer to reality than we're comfortable admitting. And that uncertainty, that not knowing, is part of being human in a universe that's bigger and stranger than we can fully comprehend. 29 days. That's all we have. 4 weeks until the blackout. 4 weeks to gather data, to debate interpretations, to prepare for whatever comes next. The WOW signal waited 48 years to be explained. In October, we might finally understand what it meant. Or we might discover that the mystery is deeper than we imagined, that the signal was just the opening sentence of a much longer story, and we're about to turn the page into chapters we never dreamed existed. Keep watching the sky. Stay curious. Stay skeptical. Stay open to possibilities that challenge everything you thought you knew. And remember,